Okay, now we're going to talk about least squares regressions. Least squares regressions has a lot to do with your R value, which we just learned how to do. You're going to have to be able to find sample standard deviations as well as sample means. So this is all things that we learned how to do in past lessons. Now we're just bringing them together to incorporate to find your least squares regression line. What this line does is it gives you a function to find future values of data. Okay, so for example, let's say that I want to do a study of how many, I want to do a study of children, and I'm going to ask them how old they are, and then I'm going to test them to see how many words they can say. So I get a 1-year-old. She's 1 year old, and I see how many words she can say. I do a test. And I get another 1-year-old. And I get a 2-year-old, a 3-year-old, 1-year-old, 2-year-old, 3-year-old. And it stays around there, 1 to 3 years old. And I test every one of them and see how many words they can say. Well, then what I can do is get all of this data and make a least squares regression line so that I can predict how many words these kids can say when they're 6 or 7 years old, just by substituting their age. Okay, so I'm doing this based on the data that I have from my study. Now, as you can see in your homework, you only have 3 problems, and it's because if you're doing this by hand, it's going to take you a while. So I'm going to do one example slow. I'm going to make sure to show every step, and then of course I'll show you how to do it in your calculator if you have a TI-83, 84 calculator, and then that'll be the lesson. Now, here I've given you the formula for least squares regression. It's y equals b1x plus b0. Now the only things that you're having to find are the b1 and the b0. Well, the b1 is your r value, which I've already showed you how to find, times the standard deviation of your y list divided by the standard deviation of your x list. And that's b1. You have to find b1 before you find b0 because you're going to use b1 to help you find b0. Now b0 is a little bit easier. All you have to do is find the averages of your y list and your x list, okay? And so you will take your average of your y minus b1, which you found, times the average of your x list. Okay, so let's try a problem. Okay, so let's say I have this data. We're going back to the car, the weight of the car, and the miles per gallon that the car has. So I'm letting you right now already know that your weight is going to be your x value and your miles per gallon is going to be your y value. The first thing I want us to do is find the least regression line treating weight as the explanatory variable and miles per gallon as the response variable. So we're going to find the least squares regression line. Okay? Okay, so cancel. The first thing I'm going to do, now that you know that we're going to find the regression line first, is we need all of these variables. Look back to what we need. We need R, we need SX, we need SY, we need the means, okay, for X and Y. So let's find R first since that's the hardest thing to find, okay? So I'm going to come over here and add some columns. Now before I was doing the columns straight up and down, and now I'm going to do them straight across since this is already how I wrote my data for X and Y. So if you remember, I have X and Y. I need X squared. I need Y squared. I need XY. Okay, so those are the 3 columns that I need in order to find my R value. Now remember, it's really easy. All you're going to do is you're going to take your X value, which is 2730, and you're going to square it. Okay, now remember, these are really big numbers. So 2730 squared is 74,52900. 52900. 2905 squared is 843,9025. That's a 0. Okay, so fill in the rest of the table. Okay, I filled in the rest of the table. Now I kind of started to wrap because I ran out of room. For example, right here, all I did was take 3625 and square it, and I got 13140,625. So that's like 1,000,000 Maybe I'm wrong. Hold on. 13,140,625. And then 4220 squared is, looks like 17,808,400. So I just kind of wrapped it around because I was running out of room. And then I did y squared. So I took these y values and squared them. So 23.8, I squared it and I got 566.44. 21.1, I squared it, 445.21. So those were all of the y values squared. Then I took x times y, so 2730 times 23.8 gives me 64,974. 2905 times 21.1 gives me 61295.5. So I just filled in the rest of the table. Once you do that, then you're going to come over here and you're going to find the sum of each column. So I'm going to come over here and find the sum of x, the sum of y, the sum of x squared, the sum of y squared, and the sum of xy. So go ahead and add those up for me and let's compare answers. Okay, so when I added them up, this is what I got. So my sum of x was 16,835, my sum of y was 98.3, my sum of x squared is huge, 58,096,975. My sum of y squared was 1981.67, and my sum of xy was 323277. So write those down, and then I'm going to write down the R value formula, and then we'll substitute in the values. Okay, so here's that scary looking formula, but remember all we're going to do is we're going to substitute our values in. So we have the sum of xy, which is 323277, minus the sum of x, which was 16,835, times the sum of y, which was 98.3. All divided by, so this is times right here, and that's just a decimal, divided by n, which is the number of points that we had. So there was car A, B, C, D, and E, so that's divided by 5. All over the square root, a huge, huge square root, x squared, the sum of x squared, which is that huge number, 580,96975, minus the sum of x, which is 16,835, squared, all over 5, close parentheses, open parentheses, the sum of y squared, which was your 1981.67, minus the sum of y, which was 98.3, squared over 5, and then close parentheses. So remember, you want to put this in piece by piece. Like I would do if you had just a scientific calculator, I would do this first. 16,835 times 98 divided by 3, 16,835 times 98.3 divided by 5. Then get the 323,277, subtract that value. Then worry about the denominator. Do this, get a value. Do this, get a value. Multiply them together. Then take the square root of that number. Then you should have this number divided by this number. You want to break it up piece by piece. So let me try it and see what I get. Okay, I put it all in, and I got my R value to be negative 0.924. And I know that's correct. So negative 0.924 is what you should end up with if you do the whole thing piece by piece. Okay? All right, so now we have the R value. Okay, next we're going to have to find the sample standard deviation. We're going to have to find Sx and Sy. Okay, now if you remember, we have to find variance first and then take the square root of that to find your standard deviation. So let's just find x first. Okay, so what I'm doing now is I'm setting up for my standard deviation just for my x values. So I wrote down my x values. You need two columns. You need your x minus x bar, and then we're going to have x minus x bar squared, because if you remember, for sample standard deviation, you're going to have to take the sum of your x minus x bar squared column and divide it by n minus 1 to get the variance, and then you're going to have to square root it to get your standard deviation. So the first thing I'm going to have to find is my average, my x bar, which is cool because I need that anyway for when we find b naught, which is the b with the little 0 on the bottom. So I'm going to have to find that anyway. So I'm going to add all of my x values together and then divide by 5. And I get 3367. So now I'm going to take every x value and subtract 3367. So I'm going to take 2730 and subtract 3367. And I get negative 637. If I take 2905 and subtract 3367, I get negative 462. So just finishing out the table, I get negative 12, 258, and then 853. Okay? Now you're going to take these values, you're going to take negative 637, and you're going to square it to get your x minus x bar squared column. When I square that, oh, huge numbers again, I get 405769, 213444, 144, 66564, and then 727609. Okay, so now that you have that, you're going to take the sum of these values. So you need the sum of x minus x bar squared. Okay, I got 282706 when I added them together. And then, wait, I think I did something wrong. Hold on. No, I'm sorry, I got a huge number. Hold on. I wrote down the wrong number. I got 1413530. 1413530. Okay? So that's what I got when I added all of these numbers together. Then you're going to divide by 4 because you're going to divide by n minus 1. We're dividing by n minus 1 because this is a sample, not a population. So I'm going to take 1413530 divided by 4 and then take the square root, and that's how you get your standard deviation. Okay, and I get 594.46 as my standard deviation for the X list. You're going to do the same thing for the Y list. Okay, so let's write down what we have so far. Okay, so I got R is negative 0.924, SX, which I showed you step by step, I got 594.46, SY, I did the same way except with my Y list, and I got 3.50. So then that means we're ready to find B1. So B1 is R times SY over SX. So that's going to be negative 0.924 SY, which is 3.50, divided by SX, which is 594.46. If you calculate that, you get negative 0.0054. That's what I got, negative 0.0054. Now you want to try to take as many decimals as you can. I'm actually kind of shortchanging it a little bit just by taking 2. You want to take about 3 or 4 decimal places after decimal for everything, and then round to whatever it tells you to round to at the very end, because you don't want to get deducted for rounding error. Okay, so I got negative 0.0054. So right now I'm just showing you the process. You want to be a little bit more careful when you're doing it by taking more decimal places after these values, okay? Okay, so now that we have B1, we're ready to find B0. Let me write this down. Okay, so B0 is Y bar minus B1 times X bar. Now X bar I had to find when I was finding my standard deviation for my X list. Y bar I had to find when I was finding my standard deviation for my Y list, so I know that's 19.66. And we just found B1, which is negative 0.0054. So then I just substitute into the formula and say B0 is 19.66 minus negative 0.0054 times 3367. And that gives me 37.8418, approximately. 37.8418. That's your B0. All right, so finally, my least squares regression line is going to be y equals. So let me clear this off real quick. Clear. Okay, because remember, it's y equals b1x minus, plus plus B naught. So you're filling in for B1 and B naught. Well, we found that B1 was negative 0.0054x, and then we know that B naught is 37.8418. And there is your least squares regression. Okay, now, if you have a TI-8384 calculator, all you have to do is go to Stat, Edit, in List 1, you're going to put all your X values. In List 2, you're going to list all your Y values. Then hit Stat, Calc, hit number 4 for linear regression. And then hit enter, and you will see y equals ax plus b. But then right under that, it tells you that your a is negative 0.0054, which was what we got for b1. And then it also tells you b is 37.8418, which is what we got for our b naught. So 37.8418. And then that's how you do it. You should still see your r squared and your r value. So you also can see that your r value is negative 0.924, which is awesome too. So you have it right there at your fingertips in just a couple of steps. Okay? Let me know if you have any questions or concerns. But that's pretty much all you have to do for least squares regression. It's taking everything that you learned and putting it together so that you can start making a prediction line. Now, let's look a little bit closer at our regression line. Now, your slope is always going to be your change in y over your change in x. And if you go back and look at the very beginning of our table, our change in y was miles per gallon, and our change in x was pounds, right? So this slope tells us the average change in miles per gallon as the increase of 1 pound in weight. Because this is a fraction, believe it or not, it's over 1. So I'm going to lose 0.0054 miles per gallon for every pound I gain in weight. And that's what it would mean. Now, the y-intercept, that is, if you think about it, here is your graph, right? And on the x-axis, you have pounds. And on the y-axis, you have miles per gallon. Well, this number is where your graph touches the y-axis. But in this case, it makes no sense because this right here is 0 pounds. How can a car that is nothing, that weighs absolutely nothing, which means you have no car, give you the miles per gallon of 37.8418? It can't. So in this particular example, it's not appropriate to interpret the y-intercept because it's outside the scope of the model. Okay, but if you could have 0, okay, and some people are like, well, Miss Ely, when would that matter? Like, when does the y-intercept actually, when is it actually appropriate? Well, for example, let's say I had y equals 30, let me change this a little bit. Let's say I had c equals 30x plus 50. And I was talking about the cost it would take someone to come out and tutor me. Okay? I would tell you, okay, you're going to pay me $50 just for going out there. I haven't even spent any time with you. You're just going to pay me $50 just for coming to your house. Then I'm going to charge you $30 for every hour after that. Well, this makes perfect sense. This is how much I'm charging you per hour. That's slope. That's rate of change. Okay, so for every hour, the cost is going to go up. Okay, so this would be cost per hour. The y-intercept makes sense here. Even if you have no money, even if you start, no hours, even if you start at 0, it's going to cost you $50 just to get me to go to your house. Okay, so that would be the initial cost, your fixed cost for me coming to your house to tutor you. So sometimes the y-intercept makes sense and sometimes it doesn't. So you just have to apply it to the word problem that you have. Okay, and so the next thing I want to show you is actually what the equation is used for. It's used for predictions. Let's say I wanted to look at car D. Now, car D, I know for sure weighs 3,625 pounds, okay? So let's substitute this into the formula and tell me how many miles per gallon I'm supposed to be getting. If you do negative 0.0054 times 3,625 and then you add 37.8418, I get about 18.27 miles per gallon. Okay, that's according to the formula. Now, according to the table tells me, if you go back and look, I got 20.3 miles per gallon. Okay, so this is from the formula. This one's from the table. So if I asked you what's the residual, I'm asking you the difference. So I'm going to take 20.3 and subtract 18.27. And I get 2.03. Okay? So I get 2.03 when I subtract it. So that is your residual. Remember, the residual is just the difference. It's the distance between the actual point and where it is on the line. Now I'm asking, is the value above or below the average? Okay, well, if on the actual point is 20.3 when it's supposed to be at 18.27 based off the data, then it's 2.03 above average. Okay, hopefully this clears this up a little bit more for you. If you have any questions or concerns, just let me know. Have a nice day.